Hello students, today we are going to write our second RTL code. The first code we wrote for AND gate and then we wrote the test bench of that code. Now here we are going to do little advanced than that. That is, we are going to use AND and OR gate in single code and we are going to write the RTL code and parallelly we are going to write the test bench for that for the simulation purpose. Now let's see what operation we are going to perform in this AND and OR in single code. Look at this. To perform this operation, we need three inputs. We are taking A, B and C. Three inputs and one output. Output is Y. So what we are performing here is, first we will be taking A and B and we will be doing the AND operation. And output of this AND operation we will take and we will do OR operation with the C. And the result will be stored in Y. So this is the operation. We are taking three inputs and one output to perform this. Students, now we are writing our RTL code. First, we are starting it with module and then we are giving module name. This name you can give any name as we discussed in the last class. This underscore you can give or you need not give. That is your wish. Whatever name you want, you can give it. And we are opening the bracket. After opening the bracket, what we need to do? We need to give the inputs and outputs. So now we are giving our first input. Next, we are giving the second input. And then we are giving third input. After giving the inputs, we are giving the output. After giving the output, what we need to do? We need to close this. So we are closing this bracket. After doing this, we need to perform the operation. Here we are having AND and OR. So first what we are going to do here is, look, here I am giving wire W1. Why I am using wire means, here we have two operations. One is AND and one is OR. Here, to save this AND, I am using W1. I'll be performing the AND operation and it will be given to W1. So for W1, we are not giving manually any values. It takes the output from AND gate. So it is wiring. We saw this briefly in the last class. So first I am giving the wire W1. After giving the wire, I need to perform the operation. So let's see the operation. Look at this. First I am assigning. I am doing data flow modeling. So I am using assign. And what I am doing is, first I am performing the operation and I am doing AND operation for A and B and I am saving it in W1. So what this equation becomes, look at here, Y is equal to W1 or C. So this is our equation now. Now we want to write the logic for this equation. So look at this. I'm writing the logic, that is assign. We are using data flow modeling. Y is equal to W1 or in C. So our OR operation is performed. Now finally we need to end the module. So I'm giving end module. So this is our RTL code for AND plus OR in single code. We have written our RTL code and we know that if you want to run it in the simulation, we need Testbench. So now let's write the Testbench for the code. In the starting, we are using module, and after using the module, obviously we give the module name. So the module name is, I am giving here as and underscore r underscore gate, and since this is Testbench, I am giving TB. This you can give any name. And then after giving our module and module name, what we have to do? We have to give the inputs and outputs. We know that for the input we have to use reg, and for the output we need to use wire. So by using that, we are giving our inputs and outputs to this Testbench. See, we are giving reg A, reg B and reg C. Reg is used for inputs, and to give the outputs we need wire. See, we are giving output wire Y. And then after giving all the inputs and outputs using reg and wire, we need to instantiate. We need to bring our RTL code inside this Testbench. So we are going to instantiate our code. Yeah, for instantiating, what we will do? We will be bringing our module name. So this is the module name which we have given an RTL code, and then we will be using UUT, unit under test. This is our instance name, and then we will be opening the bracket. After doing this, we are going to give the module port name and the Testbench. We know that we are giving this because the Testbench can control the input and observe output. Similarly, we will be giving it for all inputs and outputs. Look at this. For the input B, we are giving, and input C, we are giving, and for the output, we are giving. And then we are closing the instantiation. That is, we have bought our RTL code inside this Testbench. For that, we are writing this step. After doing this, what we need to do? The third thing is, we need to give the test cases to run our RTL code. So now we are going to give the test cases. Look at this. We are initially beginning it, and then we are applying all input connections. So these are the all possible input combinations. We need to give all these possible combinations inside our Testbench. So we are giving one by one, that is 000, 001, 010, 011, 100, 101, 110, 111. All these combinations we are giving to the Testbench. Look at this. First we are giving A is equal to 0, B is equal to 0 and C is equal to 0, and #10, it is nothing but the delay. After 10 unit delay, we are performing the next operation. So the first condition is given for testing, and next we are giving the second, third, fourth, fifth, every conditions. Look, we are giving all the conditions, and then we are finishing it. After giving finish, we are giving end. Yeah, now we are ending this, and this is the Testbench. Now let me once again go through it. The first step what we are doing is we are giving the inputs and outputs using reg and wire in the first step, and in the second step we are instantiating the design. That is, we are bringing our RTL code inside the Testbench. We are instantiating it, and after that, in the third step, we are giving the test cases for all input combinations. After giving the test cases, we are ending the process. So this is the test bench. Then next let us see for all the input combinations what should be the output. Look at this. These are the inputs combination and these are the outputs. These inputs are given here in the test cases. For this, let us see what all the outputs we need to get. For the 000, we get 0. For 001, we get 1. For 010, we get 0. For 011, we get 1. For 100, we get 0. For 101, we get 1. 110, we get 1. And 111, we get 1. So, this is the conditions that must satisfy. So today we have seen and or in single code and we have written the RTL code for that, and then we have written the test bench and we have seen what the condition it must satisfy. So students, in the next class we are going to see behavioral modeling. In the previous class, we saw data flow modeling, and in the next class, we'll be seeing behavioral modeling and we'll be going to the next level coding. So, in order to learn all those codings, please subscribe our channel and follow us. Thank you.